Good morning. Good morning. If you haven't already got your breakfast, grab something to eat, get a fresh cup of coffee, and come forward. Now, you know, I'm not going to have to call out that guy in the back, am I? He's not listening to me. Yeah, so Kevin Lasser, once you come forward, we can start. I know him. I wouldn't do that to total strangers. Yeah, get a napkin, please do. Good morning. Thank you all for being here. Kevin's pretty familiar with Automation Alley, and I think most of you are, but I'll give you the quick recap. Is Automation Alley for the past year and a half, 20 months, has really focused on three things. We do a technology and industry report in April. It was revealed, it was done in collaboration with 7 academic institutions in this area. We're already beginning it for next year, and I think we're going to have 12 academic institutions participating. They help us do deep dive research so that we can present the most current information about Industry 4.0, the state of each one of the technologies, how they're advancing, and what each company needs to do to move forward. It's a really exciting and wonderful document. It's new to us, and it was well received. We have copies of it somewhere. It's for sale, but we give it to our members. So if any member doesn't have it, you can ask for a copy. We do that in April. We do our annual Integrate conference in November. This year it will be November 14th at the Detroit Marriott. It's an all-day conference. Our first year was last year with 550 people. This year we're expecting 750. I'm the senior director at Automation Alley. If we don't hit that number because all the sales rolls up to me, I'm in trouble. So if any of you are thinking you might go, please go. Make me look good. That's a great part of our curriculum. The balance of our year is every Wednesday we have a nice breakfast and a presentation here by one of our technology companies to talk about how technology impacts manufacturing. It's our best way at making sure that the mid-sized companies can keep up with the tier ones, the OEMs, and all the other large industries as they grow throughout Michigan. We want our region to stay strong. We want the headquarters to stay here. We want the R&D to stay here. In order to do that, we have to help the small business so that the supply chain stays here. So that is our commitment. So we provide Industry 4.0 knowledge through a large research project in the spring, a conference that wraps up knowledge in the winter, and in between every single Wednesday you can come here. And unless it's like 4th of July, don't come 4th of July. The rest of them we're here. So we hope to see you all again and again. With that, I think that's enough about Automation Alley. I'm Cynthia. If you need me, feel free to reach out. Kristen from our business development team is in the back. And I am going, with that said, before I introduce our speakers, I am going to tell you Deepak has worked closely with me with Hinduja Tech, and he's your boots on the ground locally, absolutely delightful to work with, so it's always fun to put things together with this company. So we have our, I'm going to hand it over to Samit Garnani to do introductions, but I will let you know you'll be hearing from Vijay Balu today, and I think you're going to really like what he has to say. He's come in from India. Apparently he's well rested, and he did see the sun yesterday, so he's not casting aspersions on our environment today. Thank you. See you, Samit.
Morning, everybody. How are you doing today? Good morning. Thank you. Great. Thank you, Automation Alley, and thank you, guests, for joining us here today. Automation Alley is a good business partner for us, and we really appreciate the support which Cynthia and his team and her team gives us. Thank you for coming out this early morning and on a rainy day. As you are aware, the traditional value chain of the automobile is being disrupted, and that's being disrupted from all fronts. Now, a paradigm shift is in the industry is on our way, probably the biggest in the past 100 years. A shift so radical that its impact is not limited but just to the automotive industry, but will impact almost all the industries. It will leave permanent imprints on industries like infrastructure, manufacturing, energy, and healthcare and transportation. In the era of disruption, which we call today, and why should we not, the owner of the vehicle is becoming the consumer of a service, car maker is reinventing itself, as a mobility service provider. And the roads and streets, which we used to call them, are now becoming connected cities and smart cities. So at the core of these paradigm shift, there are some key digital technologies, which you see on your left-hand side, which are causing this transformation in the industry. Now, worldwide, conventional auto industry is in a deep dive to understand them, learn them, absorb them in their 100-year-old DNA and their company culture. The IT company or the information technology partners are trying to figure out how to utilize their technologies in the most complex product they have ever worked on, which is an automotive. So today, the car makers are trying to unfold the what and the why. What is this technology? Why is this? How do we use it? Why should we use it? And the conventional IT industry is trying to, so we know the technology, how and where should we apply it on the vehicle? Where the economists are saying, okay, when would this all happen? So at Hinduja Tech, we have been trying to work towards connecting these parallels by bridging the gap with the deep domain experience of vehicle product development which we have, and also tying it along with our extensive digital services vertical, digital technology vertical. Now, we are trying to guide our customers by through their digitization journey by decoding the jargon and trying to apply various digital technologies to develop practical use cases for our customers which impact their bottom line or their businesses directly. Our objective is to link why, what, how, and where, and so that customer just has to decide the when, how to implement, how soon to implement. Once you decide the other four, then when becomes easier. So our focus today is not only discuss about the fundamentals of some of the digital technologies, which Vijay would say, but also talk about some use cases which we're able to actually attack on these four fronts simply enough for our customer to actually just know when to implement, and easy enough for them to decide, okay, we should implement this today to get the business impact tomorrow. So for this, I would like to welcome Vijay to the portal and kind of explain, go through this. Thank you.
Thanks, Sumit. Good morning to all. I'm Vijay. I lead the digital consulting and solutions practice of Hinduja Technologies. I've been working with global manufacturing organizations, advising them in their digitization journey, especially focusing on data science. And today, as Sumit talked about, as the automotive value chain is getting disrupted through the digital technologies, and you see a plethora of digital technologies lying here. The focus of today's presentation is going to be on neural networks and IoT in terms of how these digital technologies can unlock a value, especially in the context of product development to reduce their product development cost, warranty function, on how AI can help them to reduce warranty cost, and for a fleet owner, how can they better predict the vehicle downtime to improve their profitability. Let me move on to the next slide. This is the structure of today's presentation. We will start with what's the Industry 4.0 canvas is looking like, and why do we need Industry 4.0 as we speak today. Then we will quickly talk about artificial intelligence, which is in a way what we call as an applied artificial intelligence with regard to both machine learning and neural networks technologies. And why is it so important for manufacturing organizations like us? And what kind of value that we can bring out from the data? It's what I would cover up in section number 2. And we will also talk about certain industrial use cases around artificial intelligence, especially from a manufacturing context. The third section of our presentation will talk about some amount of the case study work that we have done with certain auto OEMs. We'll walk through you one key use case of artificial intelligence, how AI can be applied in the context of automotive industry to sort of help them make contextual insights to product development function, warranty function on the fleet owner, right? And we will also quickly wrap up with the demo. We will show you how we can actually take data from different functions and provide the contextual insights to the enterprise stakeholders. And we will have interactive discussions towards the end. This is the sequence of today's presentation. And let me move on to my first slide on Industry 4.0. And I think there are a lot of talk about what is Industry 4.0, and most of us are aware of Industry 4.0 fundamental concepts. But what I would like to insist here is that Industry 4.0 is not yet another IT project, right? It's a holistic program for the enterprise, and it means either revenue growth or profitability for the organization. And now it's all about the convergence of physical and digital worlds, right? And on your right, you can see a plethora of technologies, how Industry 4.0 can be enabled with these digital technologies. And when we say the physical and digital world, what we mean by is that today, if you're an automotive manufacturer, you not only build products, but you also, in a way, deliver services and experiences to your end customer. So you have a whole context of products, experiences, processes, and services. And then here in a digital world, what you can do is that you can not only connect the physical and digital world seamlessly, but you can look at the data coming from the physical world, analyze them, and then drive back to make intelligent decisions, take prompt actions, and you can seamlessly move from physical to digital, again to physical. Let me give you an example with one of the digital technologies that I'm talking about. Take first digital technology, which is networks. So we are talking about social networks here. Traditionally, in an automotive product development, the product planners go to the market, conduct voice of customer clinics, understand the pain points of the customer, and then they actually come in-house to collect ideas to solve these problems, and then sort of build their vehicles in terms of features and options, right? But here is today, open source or crowdsourcing innovation models are so popular that, for instance, manufacturers like Local Motors actually crowdsource ideas from car enthusiasts, and then they actually build their own car in-house. Now, this is a classic example of how crowdsourcing can harness mass innovation and reduce your product development life cycle, especially in the fuzzy front end of product development, by collecting the ideas and converting these ideas into features and options. Now, this is an example of how social networks can unlock value to the organization. Now, this is an example of how you can convert the digital and physical world, but from the digital world, Local Motors actually 3D print these parts, which means from the digital experiences that they gather from their community, they move on to the additive manufacturing or the 3D printing, where the car parts are getting printed, right? So you're moving seamlessly from a digital world to a physical world by looking at the data and then analyzing and then taking back some prompt actions. Take, for instance, blockchain. I think blockchain has been wild for now, and there are a lot of use cases that have been talked about blockchain, especially in the financial world. But in the context of manufacturing, especially in the automotive industry sources a lot of parts from their supply chain networks. Now, as an OEM, how do I make sure that these parts are genuine? Because today you have Tier X suppliers, Tier 1, Tier 2, Tier 3, and there is a long supply chain, and you source parts across your supply chain network. How do you make sure that these parts are genuine? And how do you prevent the counterfeit parts? Now, blockchain and IoT can help you to trace the authenticity of the parts so that there are no non-genuine parts in the entire supply chain, and your customers actually pay for the genuine parts, right? It's a distributed network. So there are a lot of use cases around these digital technologies, and what these digital technologies help you to do is to seamlessly move from a physical world to a digital world with data as the oil, and analyze the data, and then you take insights out of the data to take some corrective actions. And the focus of today's discussion will again revolve around neural networks, which I will actually go through in the subsequent slides. Moving on to the next slide, where we would like to highlight why Industry 4.0 now, right? So it has been for a while now, but why are we emphasizing on Industry 4.0? Now, on your left, you could see the key industry drivers. I've given some examples from automotive industry context perspective, but it could be an any manufacturer. Let's say, for instance, we are talking about a mobility as a service model, where today customers don't want to own a car, but they would like to subscribe to the car ownership, right? So we are talking about car as a service. But this particular trend is not only applicable to automotive industry alone. Take, for instance, an industrial compressor manufacturer. Compressor manufacturers typically make compressor equipments and then sell it to their end customers. But today there are organizations where they are moving into a model from selling the compressor equipments to compressed air as a service. So which means as an end customer, I will only subscribe to the amount of air that I need to consume. So in a way, I don't need to buy an equipment as a whole, but I actually subscribe to a service. And this can be possible only if you understand your real world usage behavior of a product in the field. And we are talking about, of course, automotive industry is known for cost and revenue pressures. So this is yet another driver or a trend that we are seeing in the industry across the value chain. And the processes have become extremely complicated. So there is a need for harmonization of the processes across your plant locations, across your different sites, across the different markets. So these are all some of the trends that we actually see on the left. On the right, you could see the technology readiness. I would like to insist upon three important drivers here from a technology standpoint. The first is the data. Of course, we all, without knowing, we are to generate a lot of data across the enterprise functions. Are we making enough, are we taking enough value out of the data? And now today, when we talk about data, it is not only about the abundance of data available, but also with the help of technology, analytics and visualization, you can unlock the data and then make some meaningful insights out of it. So today, the data, voluminous data generation and the availability of technologies to support or convert the data into insights is available. The second important thing that I would like to talk about is the computational power, where Moore's law come into picture. Let me give you a classic example of how computational power has increased over a period of time. Now in 1985, Cray 2 was the first supercomputer which we were introduced to. Now typically the computing power is measured in gigaflops, the CPU power, and the computational power of Cray 2 at that point of time was 2 gigaflops. Now 30 years later, here is a device which is close to about 120 gigaflops. And you know what the device is? It's iPhone 6. So that's the kind of tremendous increase in computational power today available. And that computational power is an important driver for Industry 4.0. And finally, connectivity. Today, we are all talking about how machines to machines can communicate seamlessly through a lot of communication protocols available, be it in terms of Zigbee, Bluetooth, or even some low power wide area networks. Now, all these three technological drivers are ripe enough for Industry 4.0 to welcome. Now, what is important to notice here is that on one side, the industry itself is getting disrupted. On the other side, the technology is poised to take over, and that's where the marriage of the industry trends and the technology readiness happen, and that's where we see Industry 4.0 is already in place for us to take maximum benefit out of it. Now, having talked about what is Industry 4.0 and why Industry 4.0 for today's manufacturing organizations, let me shift my focus to artificial intelligence or neural networks. Now, I think artificial intelligence is something not a very new phenomenon which is happening here. It has been there since 1950s, and we have been looking at a lot of computer-aided games defeating certain chess champions through artificial intelligence. But again here, the computational power and the availability of the data helps artificial intelligence, helps organizations to harness artificial intelligence technologies. And what I would like to show here is how typically organizations can adopt any artificial intelligence program. These are nothing but, artificial intelligence are nothing but self-intelligent algorithms where they actually sense something, they process a data and then learn from it. So it's a closed-loop feedback where these algorithms actually are trained to learn from the data themselves, and then the output of this particular process is either an insight or a conclusion, which will help stakeholders to make intelligent decisions. Now, how do you actually go ahead and then go with a typical artificial intelligence journey? Now, we start with identifying the right use cases for your organization. I mean, here is where most of the organizations fail to understand that identifying the right use cases is the success of any artificial intelligence program. And when you identify the set of use cases, you may want to understand what I am going to predict and where I am going to predict. So the first step is about your end goal. And this end goal typically has to be aligned with your business priorities. And then when you move on to identify the predictive system, you actually need to formulate this whole problem into the analytical domain. So you have a business problem. Let's say if you want to predict what sort of customers will leave from my particular service, right? And so you are trying to predict a customer churn, who will probably leave or who will probably not turn into my next service when they actually visit my garage. So that's the problem that we are talking about, and you may want to translate this business problem into an analytical problem. And moving on, you may have to identify the right data ecosystems both within and outside your enterprise to sort of collect the data, identify the right data sets, and then you sort of do some cleansing of data, because a lot of data comes with noise, and it is equally important that you actually identify the right data and then cleanse the data. And once you cleanse the data, and that's where you start constructing a neural network. And when you say artificial intelligence, there are two broad techniques that artificial intelligence work upon. One could be a machine learning, and the other could be a deep learning. And deep learning is typically enabled through neural networks. And imagine this, today in our human body, we have about 86 billion nerve cells called neurons. And these neurons help you to transmit messages effectively from brain to the other parts of the body. And artificial intelligence technique, especially neural networks, mimic this kind of human biological interaction, where you have a lot of neurons constructed with nodes. And when you fed the data into the nodes, these data is getting transmitted to the nodes. And there are certain weightages assigned to the nodes to commute the output function that you want to calculate. And that's where you build a model, you train the model, and the neural network is able to learn from the model using the data that is fed to the neural network. And what does the neural network do? The neural network actually looks at certain unknown relationships which human cognitive bias, which human cannot able to figure out, because there is a lot of data, and you cannot actually understand the unknown relationships by merely looking at the data. Of course, based on our experience, we would be able to understand where do we want to focus. But there are certain unknown gray patches with the kind of voluminous data generated. Neural networks can help you to identify patterns with the data and then give you some meaningful insights. Now, based on the insights, the enterprise stakeholders can make some better decisions. And the most important part of this whole cycle or whole journey is all about how do you evaluate the success of any model, of any artificial intelligence program. That's where you may have to constantly look at feeding the output of a particular neural network, train the data, and see whether what's the business value that you're getting out of this whole program. And you try to quantify the business value so that you can actually improve your AI program. So this is how a typical AI program works. And moving on to some of the use cases in manufacturing on where artificial intelligence can be applied to. This is not an entire set of list. This is just an illustrative list where we have where we wanted to actually look at the high business impact artificial intelligence use cases. Now, as you see here, this is a traditional manufacturing economy life cycle. It starts with new product marketing, new product design and development. How do you build your products in your shop floor? How do you service them? And then how do you recycle them back, right? And artificial intelligence can help you to look at the data across each of these functions, not in silos. Because today, as your product moves from your drawing board to your field, it has got a lot of touch points. And across these touch points, the product generates a lot of data. And as an enterprise owner, you are a custodian of data. And how can you make better insights out of the data is what we are trying to see. For instance, real world failure patterns prediction. Now, this is one of our case study which you will also see here in terms of how product development team can understand the real world product usage behavior so that they can better design their own products. And what we mean by failure pattern prediction is that, let's say that you have about n number of components in your product. How can you understand one particular failure of one component impact the failure of another component? And if you have that particular insight, then you can also look at redesigning that particular component better when you consider for your FMEA analysis. Right? Take for instance the supply chain management or production. Especially in the shop floor operations, today with most of the sophisticated shop floor machines that we have, most of them come with PLC, SCADA, historian technology investments, and they all generate a lot of data in terms of cycle time, mission parameters, operator attributes, so on and so forth. So how do you actually predict the downtime of a mission before it actually happens? And now artificial intelligence can help you to look at the data generated from these missions in terms of their downtimes, in terms of their key process parameters, and help you to predict the downtime. And if you are able to predict the downtime, you would be able to save at least 8 to 10% of your downtime in your shop floor. Take for instance mission process optimization. I mean every manufacturer adopts statistical process control or SQC in their own shop floor environment. But even then there are certain product defects that happen on your shop floor as well. Now what manufacturing process optimization use case can help you is that look at the failures that are happening on your line, and then look at your mission process parameters, and then smartly how can you actually optimize these mission parameters so that the missions can actually self-heal themselves, and in terms of providing you a right set of parameters to get a right product. Now take for instance your sales and service function. Now traditional spare parts function has a lot of supply chain elements, right from an OEM to a distributor to a retailer, so on and so forth. Now there is a lot of bullwhip effect that comes into the picture where the adjacent entities don't know the actual demand of the predecessors. Now what artificial intelligence can help you is that with the help of these sensors or IoT technologies enabled in each of these entities, you can track the real-time visibility of the supply chain, and you would be able to move from a demand or a forecasting based model to a consumption based model in a way that traditional forecasting models work on historical data, and you actually forecast that this is going to be my spare parts on a particular given month. But now with the real-time visibility using your sensors, what it helps you is that you can precisely understand what the demand pattern is in your predecessor network of your supply chain, and thus that will help you to bring down your inventory carrying cost significantly. So these are some of the use cases that we have put together. We have talked about customer churn analytics. Take a classic example of an automotive service garage where a customer walks in for a service and he gives a car, he does the service, and then he walks away. But is he really satisfied with the service? Will he come next time to that particular service garage? We don't know. And what can happen is, using the data generated from the dealer's end, using the data generated from surveys, and using the social media data as well, you can try to understand whether the customer will actually step in the next time when he needs a service. And let's say if you predict there is only 20% probability that the customer will walk in for the next time for the service, you can actually make smarter decisions by talking to him, understanding what his pain point is, and maybe even provide some personalized offer to retain that particular customer. So customer churn prediction analytics will help you to improve customer satisfaction, thereby increasing your customer base. So we have talked about why AI is important and what kind of use cases from a manufacturing standpoint. How do I typically, how does an organization need to take an AI program, right? And what we recommend, and based on our experiences, we suggest that organizations must take a phased approach in order to go through this entire AI journey. And the first phase of this particular journey is all about identifying what you want to solve. What are your business challenges? And how do we prioritize these use cases? And this is where the domain expertise and the technology expertise come together, and then work with a particular manufacturer to understand what kind of use cases are important for that particular manufacturer. And then moving on to the pilot out, where you actually run small pilots, because pilots will help you to improve your confidence, and it also help you to minimize or optimize your investments from a technology standpoint. And when you run pilots, you can actually decide to actually run with certain open source tools, and these open source tools are available plenty in the market, and with the help of the right partner, you can actually run certain pilots. And the most important thing in running a pilot is about doing a data maturity assessment. Typically, organizations think that they have a lot of data generated across the enterprise, but when they do a pilot, we come to understand, while the data is available in large numbers, they may not be in a right format to convert from one form to another form for the algorithms to work. They could be in an unstructured format, they could be in a different format, they have to be cleansed, the noises have to be removed, the anomalies have to be taken care of, right sampling approach has to be in place. Now the data maturity assessment step will help you to take care of all of these points, and it will help you to make better decisions when you want to scale up in the next phase. Now, once you run these pilots in the form of proof of concepts, you talk to your stakeholders, understand what the value that they are seeing in this particular proof of concept program, and gather your feedback. And this helps you to sort of learn from your experiences before you actually scale up in the next phase. And the scaling up will typically happen when you understand what the value that this particular POC or this particular program will bring to the organization, and then you sort of integrate with your enterprise IT tools, because finally these tools have to be integrated with your to-be IT tools in terms of workflows and in terms of providing recommendations to the stakeholders. And scale up is an extremely challenging phase, because you may have to actually gather requirements across the organizational stakeholders, do a proper blueprinting of the design, and then run this program in an agile mode so that you actually reap benefit out of this. Final phase of this whole journey is all about institutionalizing. Institutionalizing is a phase where organizations need to understand how can we make data, how can we harness data to make better decisions. So typically C-level or a senior level management support or sponsorship is required for any artificial intelligence program, and organizational business leaders also have to understand the pros and cons of artificial intelligence program, and they have to be open from a culture standpoint to sort of make decisions using data. Now, based on our experiences and secondary research, these are some of the critical success factors of any AI program. It all starts with identifying the right use cases that you want to solve. As I said, we may have to identify the right predictive system based on your business pain points, which is extremely important. The second important critical factor is what kind of data ecosystems that we are going to harness. You might have a lot of data systems generated both within the enterprise and outside the enterprise, and how do we actually make use of those data ecosystems? Do we get the data in a right format? What kind of data ecosystems are relevant for this particular POC? These are all the typical decisions that we may need to make in this particular case. Now, governance plays a very important role, as we saw in our experiences as well. This is typically because we found that while data is getting generated across the organization, there are ownership or the custodian of the data lies across the functions. So for instance, if you talk about warranty data, my warranty manager is the custodian of that particular data. If you talk about FMEA data, product development engineer would be the custodian of the data. But when we want to make a holistic insights, we would like to actually take data from warranty function, product development function, and then provide you a contextual insights to each of these stakeholders. So a cross-functional support is actually required with a proper governance structure so that everybody actually gets a buy-in for such kind of programs. Then moving on to tools and techniques, today there are a lot of commercial off-the-shelf tools are available as far as AI is concerned, as far as open source tools are actually available. So we may have to understand what kind of tools are required based on the organizational to-be technology architecture. And finally, on the talent. Imagine this, out of 150 million workers in US, there are only 0.2 million workers who are skilled in data science domain. So there is a scarcity of data talent across the globe. And how do we actually bridge the gap? There are different ways that organizations are trying out to bridge the gap. One is about training their own employees, making sure that they are aware of data science. The other approach is also about partnering with someone who is expertise in this particular field, and then take their talent pool and then work together. So talent is extremely critical, because you may have to build this data science talent within the organization, even after institutionalized phase, so that the whole AI program actually moves seamlessly within your organization. Now, we will move on to one of the case studies, especially with AI. So we talked about different use cases from a manufacturing standpoint, and we have been doing, I've been showing one case study with one of our customer, an automotive OEM. We are not showing the actual data here. We are just showing some illustrative data when you come to the results. But let me actually walk you through what the use case is all about and what kind of pain points they faced. Now, the biggest pain point is all about how do I improve the reliability of products. So that's the objective of this whole program is. Now, there are different stakeholders in the enterprise whom we actually talk to. The first person is the warranty manager. And the warranty manager typically says that he ends up in spending a lot of warranty cost year on year. In fact, while these problems are client specific, we also understand that these problems are industry specific, and the statistics that you see here are relevant for a commercial vehicle industry in US. So for instance, you can see there is a 3% year-on-year increase in the warranty cost. And then at least 1 in 2 product development executives endorse that longer test cycles are the primary reason for design iterations and product launch delays. And then if a fleet owner actually ends up with his fleet not running on the road, the impact of monetary loss is close to about $600. So these are all some of the challenges that we heard from this particular customer. And especially in the context of the product development team, they are not able to correlate the actual field insights with their design, validation, and verification plans. This means there are a lot of failures that are happening on the field, which they are not able to predict it well in advance in their lab testing cycles. And from a driver standpoint, as customers are demanding more and more reliable products, and organizations are initiating a lot of modular development programs, this is extremely important in the context of creating a better mind share with respect to the customers. Now, these are all the challenges that the organizations went through, and these are not the challenges that this particular organization faced, but these are general industry challenges. Moving on, now there is a lot of data that is getting generated across the value chain, especially in the context of reliability. Now, the product development generates the FMEA data, and these are basically unstructured data in the form of text, and then you have component test reports. Whenever one component is getting tested in their test rigs, you generate your test reports in PDF files. And then we found a lot of track testing data. Supply chain, we found a lot of supplier quality inspection data lying in the field. Then manufacturing end-of-line testing data. So we have almost dealt about close to about 25 GB of data, and this is just for one particular product model and for a few aggregates. Right? And what we did was we looked at a plethora of use cases to solve this particular problem on how do we improve the reliability of products. Some of the use cases have been listed here. When we spoke to the warranty manager told us that how do I make a decision that today if my product warranty is about X miles, and if I have to increase the product warranty from X miles to 2X miles, how do I know which product will fail? What would be my cost impact, right? So that's one of the decisions that a warranty manager wants to take, which means he has to predict failures of his to-be product warranty decisions even before he wants to make that decision of how do I extend my warranty from X kilometers to X kilometers. Now, industry faces fraudulent claims a bit, and this customer also wants to understand how do I actually predict fraudulent claim, because there are a lot of customer abuses happening on the field. Now, the third use cases that we also heard from product development team is all about how do I analyze and validate the reliability of my existing components. This is extremely important because once I know what is the reliability of existing components, I can actually better design my products for the new models, or I can actually fine-tune my testing cycles to suit the real-world usage behavior. Then the manufacturing manager wants to understand, while I have my shop floor processes in place, how do I correlate my manufacturing process capabilities with the failures happening on the field? Failures could have been due to engineering design, or it could have been because of the supplier parts issue, or it could have been even to production process issues. Now, the manufacturing process engineer is more interested to understand, how do I know what kind of manufacturing process capabilities do I have when I compared with the failures that are occurring on the field. And finally, a fleet manager or a service manager wants to understand, I want my vehicles to run 99% of my time. How do I make sure that my vehicles are not down on the road? So these are some of the use cases that we looked at, and all of these use cases can be handled in artificial intelligence. But for today's discussion, we will only focus on point number 3 and 5 in terms of analyzing the reliability of components. Now, we actually looked at all the data that I have talked about. We actually focused on few aggregates, engine and gearbox. We looked at the taxonomy of engine. We looked at their bill of materials. Using our own domain expertise, we could understand how does these different components actually fall into. And we applied certain algorithms from the data coming out from warranty, from the sales, from vehicle telematics data. And then we figured out this. On your left, what you could see is a typical field failure distribution of one particular aggregate. As I said, these are mock-up data points. These are not actual data points. But interestingly, what we obtained was, let's say if you're talking about engine has different components. And what you can do is, using the AI algorithms, we helped them to predict what is the probability of failure at a given point of time. And this is possible because of the warranty data and the vehicle telematics data. And what you can infer here is that while engine has different components, idler gear is one particular component that pulls down the reliability of the whole engine. And you might actually get different insights when you actually plot this graph to figure out which is the weakest component in your whole aggregate which pulls down the reliability of your whole component. Now, not only this, if you develop this model, you can also predict what will happen next in terms of what is the probability of failure of a given component if you want to actually take about 300,000 miles, 400,000 miles, so on and so forth. Now, on your right hand side, what we can also figure out is how failures are interdependent across each other with respect to different components. So for instance, the example that we have given here is about how engine and gearbox are closely related. For instance, if a fuel pump timer has failed, in this example, for instance, fuel pump timer has failed, there is a 30% probability that the thrust sleeve of gearbox will also fail, right? Of course, this is an illustrative example, but what is more important is how do you understand the interdependency of failure on one component versus another component. What it helps you is, it helps you to look at your FMEA process in a holistic manner, where when you look at the failures of engine, you also look at the failures of gearbox. While you might have been, some of these failures might have been known to you, but as I said, there are certain unknown relationships that can also pop up when you have mountains of data coming in from your field. Now, all these things will help you to enrich your FMEA process, make better decisions about your design, and eventually help you to shorten your testing cycle. Now, what we will do is we will quickly move on to a demo on how we are enabling this artificial intelligence using certain algorithms. won't help. Right. So Relay is basically a platform which basically helps you to collect data across the organization, right from your FMEA data, component lab testing data, vehicle telematics data, warranty data, and then help you to unlock value out of the data to predict failures of your particular aggregate. Now, we talked about three personas here. One is the product development engineer, warranty manager, and fleet owner. Now, let's say that a PD engineer wants to understand how this platform can help him to predict failures. Now, he selects a vehicle model, and he wants to look at, let me show you even before we go here. Now, what happens is, this particular platform helps you to connect entities across your enterprise. What we mean by entities is, these could be your missions, these could be your databases, or these could be your vehicles. And all these entities will generate data. And what you can do is, you can actually configure these entities in the platform so that you can collect data seamlessly. And then you transform the data, and artificial intelligence algorithms embedded in the platform will help you to predict certain problems that you want to solve and uncover insights. Now, you can configure your databases. For instance, if you have an SAP system which documents your warranty data, you can configure your SAP database over here. If you have a NoSQL data, you can actually configure this. And then you can also configure your vehicles, and using the telematics data, you can actually take all the data over here. Now, once the PD engineer actually logs in and then he sees the vehicle number, what he is interested upon is, he is interested upon to see the real world usage pattern, and then he wants to predict what is the probability of failure of this particular component in its life cycle. So let's say that he wants to actually understand failure at 20,000 miles. What he sees is that this is how the probability graph will look like, and so he says that there is a 59% probability that this particular component will actually fail at 20,000 miles, right? And not only that, he can actually deep dive from an aggregate standpoint to a component level as well. So what you see here is that there are different components here, for instance, fuel injection pump, idler gear, gearbox, so on and so forth. And these are all the probability of failures of individual components. And he can actually understand which is the weakest link in this whole aggregate component that actually pulls down the reliability. He can also look at the top 5 failure modes of this particular vehicle. Now, let's say that he wants to understand more about what is happening in my fuel injection pump, and he actually drill down deeper to see whether what kind of components exist in a fuel injection pump, and then see whether what does each component reliability looks like. You can see here that this is the reliability curve of a fuel pump timer, which means there is a 51% probability that this will fail. And then he can also see the failure interdependency. So he can see what is the impact of failure of fuel pipe on other components. So for instance here, if a fuel pipe fails, there is a 25% probability that the counter shaft will also fail. And these are all coming from the data that is getting generated from warranty and vehicle telematics. Right? And he can also see the top failure modes of fuel pipes. And since we are talking about artificial intelligence, now as I have shown you earlier that you can actually configure different types of data, you can also see here that there is an alert that pops up that actually says that during your FMEA process, you would have anticipated some failure modes. But if you have uploaded the FMEA file over here, and then the algorithm actually compares the list of failures that you have documented in your FMEA process versus whatever failures that are happening on the field. And then it throws you an alert to see whether are there any unidentified failure modes that are happening on the field which you have not considered as part of your FMEA process. And you can go ahead, you can validate it, and then you can go ahead and then add it into your FMEA library. So this is how the data helps you to take some proactive actions instead of taking some reactive decisions. Now let me give you another use case that we talked about, which is the vehicle downtime use case, where imagine that you are a fleet owner or a service manager. You wanted to understand, or you wanted to make sure that my vehicle has to be on the road 99.9% of my time. How do you make sure that your vehicle does not fail? Or how do you make sure that even before my vehicle fails, can I take some proactive actions? Now, this helps you to see what kind of fail. So here is a fleet manager, or here is a service manager who actually sees here that there are about 37 vehicles running in this particular geography. These are the alerts that I see, one particular vehicle which has a critical alert, which means it is going to fail in the next 20,000 miles. And you can actually hover over here and then see how these vehicles are, where are these vehicles running. And you can actually see one of the vehicles. So he can see one of the vehicles, what kind of health parameters that these vehicles have, and how do I predict whether the vehicle will fail or not. So for instance, you can see here that there is a probability of 32% downtime for this particular vehicle. And what a service manager can do is that he can actually schedule a service to the nearest service station depending on the geographical location of this particular vehicle. And he can also look at the driver behavior score here. So you can see a driver score. So depending on how driver drives that particular vehicle, there is a score coming out. And you can also correlate whether a rash driving is a reason for a particular failure. So these are all possible because of the algorithms that are seamlessly working together to collect data across the enterprise. So to conclude, I think Industry 4.0 has already arrived. It's all about the marriage between physical to digital world, and how organizations can actually collect data, analyze data, and then seamlessly transfer from the physical to digital world. And we also talked about the key drivers of artificial intelligence in the today's context, with the abundance of data available and the computing power available, how AI can unlock value to manufacturing organizations like us. And we talked about different use cases of manufacturing specific to automotive context, and how AI can help manufacturing organizations to reduce their warranty cost, or reduce their downtime of vehicles, or even reduce the product development cost from a product development function standpoint. That's all I have for today. Thanks for your time. Appreciate it. Thank you. We can move on to the question and answers if you have some questions.
Hi, Robert Brooks with Sumitomo Corp. Your data that you're using to build the model, what level of maturity does it need to be? That's my first question. Second question is, knowing that all SAP systems are not created equal, what kind of level of data do you need in order to go down to the level you were showing in your example of the individual components in the assembly? Because often that's not really known.
Right.
Thank you.
Thank you. Let me take up that first question in terms of data maturity. I think data maturity is extremely important as far as our modeling is concerned. What we also do is, using our domain expertise in this particular case, we have labeled the data very clearly. We precisely know what kind of aggregate that we are talking about, and what kind of parameters are related to that particular aggregate. So we have come out with a taxonomy definition of how you can use that particular taxonomy definition to cleanse and filter the data, and then take it forward into your model. And of course, that has to be done as a one-time exercise before you actually build a model. So that answers our first question. Second question is all about SAP maturity. But the work that we have done here, the customer uses SAP. So we have pulled the data only from SAP warranty system. But here in this case, the customer has clearly identified, so there was a well-defined taxonomy of compliant code, compliant group, mapped to the component group. So which means you can clearly deep dive from your L0 product structure to our L3, from an engine to the next level to the next level. So that was available because the customer has already done that in terms of product taxonomy definition. But if you don't have that kind of taxonomy, we may have to first do it and then take it forward in terms of modeling. Otherwise, if your taxonomy is not consistent, then there will not be a single version of truth across the organization. Yeah. Does that answer your question? Thank you. Yeah.
Who do you use for your IoT? Kevin Lasser jumps technology. Who do you use for your IoT platform? Do you use your own IoT platform?
Yeah. So IoT platform, we have our own open source IoT platform. But having said that, in this particular case, it was an open source IoT platform. But as a IT services company, we are technology agnostic. We look at Microsoft Azure, ThingWorks, IBM Watson, and so on and so forth. It again depends on what customers' IT landscape is and how do we actually seamlessly solve that particular business problem. In particular, yeah, we have been exposed, but in this case, it's an open source IoT platform. Thank you.
There we go. Hi, I'm Kristen. I'm with Automation Alley. I have a question about variables that can't necessarily be captured digitally. How are those factored in, or how are visual inspections factored in that can be subject to human error? I'm specifically thinking about a dust tape test for the quality control space, which is commonly used in automotive and oil and gas. How is the AI dependent or separated from the visual inspections, which can be subject to human error factor?
Okay, so visual inspection is an emerging use case as far as artificial intelligence is concerned. People use deep learning techniques to understand or classify the defects from non-defects. The only challenge there is you need a lot of image data to train the model. And then someone has to have a good domain expertise to understand what the particular image of that component is all about and where is that particular failure is happening. Because unlike your Google Photos, where today Google Photos help you to say that you can actually label the name of the person if you actually tag it with the respective photos there. And then it actually understands the image. But in case of manufacturing, your component complexity is far more. I mean, the complexity is far more. So let's say that if there are two or more aggregates which are closely intertwined, and if there is a failure which is happening in between them, then you have to precisely understand what that particular component is and what that particular failure is. So your efforts on training the model is significant, right? And that's where a lot of companies are trying to address the problem by labeling the particular image data and then taking back to the model.
Mason Hamden from Aishin Technical Center. She had the first section of my question. So the second question would be, how long does it take to integrate physical data into what you need for artificial data to work? Do you have examples, and how long does it take?
Right. So again, it has to be contextual. It depends on the problem that we are solving. But let's say that we are talking about a vehicle telematics use case, where let's say that your vehicles are running on the field and you wanted to capture the data from the vehicle and then you wanted to see whether how your vehicle's performance is all about. Now, assuming that you already have a vehicle telematics module in place, which will help you to collect data, right? All you need to do is put up an IoT architecture to seamlessly collect the data from the vehicles and then put it onto the cloud and then get back to the platform. The setup of this whole vehicle telematics unit alone might actually take somewhere about 8 to 12 months of time. We are talking about a whole set of vehicles over there, and then you may have to actually use this particular platform to collect data. Now, these algorithms are pretty much available. They have to be fine-tuned to a particular manufacturer, particular aggregate. So customizing these artificial intelligence algorithm for the purpose of predictive analytics might take about 3 months of time for a proof of concept or pilot. But yeah, the first half is all about putting those data acquisition systems in place. Thank you. Any other questions? Yeah. We can actually mask some part of this presentation and then share it with Automation Alley, and then we can circulate it to the participants. Thank you. Thank you. Thank you. Thanks for your time. I appreciate your time. Thank you.